Okay, so complex conjugate. Right here. Complex. Oh, not the same number. Oh, this is much better. I think I spelled that wrong. I think it's a J here. We're gonna J. I think I'm gonna have to send the other tablet back. Okay, so the complex conjugate, all you do is change a sign in the middle. Okay, so we're gonna write that down, change middle sign. Okay, so what that means is this sign here. Okay, so 2 minus 2i, we would change that to 2 plus 2i. That's it. You change a sign in the middle. Okay, so if I take a look at this problem again, I have 10 plus 2i over 2 minus 2i. I am going to multiply that by the complex conjugate on both the top and the bottom. So 2 plus 2i on the top and the bottom. Okay, so that means I'm going to have to FOIL on the top and FOIL on the bottom. So let's start on the top. All right, so we have 10 times 2, that's going to give us 20. 10 times 2i is going to give us a positive 20i. Then I have a 2i times 2, that'll give us a positive 4i. Then I have a 2i times 2i, that will give us a positive 4 I squared. Okay, then let's simplify that. So we'll take the I squared, cross it out, make it a negative 1. So that becomes positive 4 times negative 1. So that'll be a negative 4. And then, let's see, we'll bring down the 20. We can go ahead and combine these like terms. 20i plus 4i will give us a positive 24i. All right, so we have 20 and then minus 4. We can combine those. That'll give us a 16 plus 24i. So that's my numerator. I'm just going to put an n right there for numerator. And then I'm going to go ahead and work on the denominator. Let's change the color for that one. All right, so in the denominator, I'm going to go 2 times 2. That'll give me a 4. Then I have a 2 times 2i. That'll give me a 4i. Then I have a negative 2i times 2. That will give me a negative 4i. Then a negative 2i times a positive 2i will give me a negative 4i squared. All right, so I changed the I squared to a negative 1. And then I have a negative 4 times negative 1. That will give me a positive 4. If I combine my two middle terms, and this is the reason why we use the complex conjugate, because they're going to cancel out. Okay, so those cancel out, and I get 4 plus 4, 8. So that's my denominator. So now my problem looks like this. I've got the numerator, 16 plus 24i, over 8. Can I leave it like that? No, I can reduce that. Just like you would if this were an x, you can go ahead and reduce it. 16 divided by 8 is 2, and 24 divided by 8 is 3. So 2 plus 3i. And then that would be the final answer.
On the test for this type of problem, what's it gonna, like, we're gonna see the problem, what's it gonna say?
Number 5, it would just say simplify. Okay, so let's do some more practice with this. Okay, so we are combining addition and subtraction. So my first set of parentheses, I'm just going to bring down 3 plus I. Now I'm subtracting something in parentheses, so I'm going to distribute it. So I'm going to distribute the minus sign here. That's going to be minus 4. And then here, the negative times negative here will give me a positive 2i. And then this is plus, so it's just plus 6 minus 7i. Nothing changes there, just with the minus sign. And then let's combine our like terms. So my numbers, I've got a 3, negative 4, positive 6. So 3 minus 4 is negative 1, plus 6 is 5, positive 5. And then I have I plus 2i minus 7i. So that's 1 plus 2 minus 7. So that'll give us 3 minus 7, negative 4i. And that's it. One thing you can do when you're looking at number 2, you notice they're exactly the same, except the sign in the middle. So that means the middle term cancels out. Okay, so one thing that you can do is you could just do first and last, because really if you're foiling and you know these are going to cancel each other out, you really can do the shortcut of first and last because they're exactly the same with different signs. So you could just go 6 times 6 is 36, and then my last I times negative I is a negative I squared. I squared is negative 1, so this becomes 36 minus negative 1. So that's double negative there, becomes positive. We get 37. And then when the problem starts with an I, sometimes you might see the answer written like this, or sometimes if it's multiple choice, it might look like that, okay, because it's still trying to keep the I term, or it's still being written as a complex number, okay, with a 0 in front of the I. So this would be like written as a complex number, and then this would be fully simplified. So you might see that multiple choice, but short answer, you could just put a 37. Okay, but if you see that multiple choice, don't be alarmed. It's the same thing. Okay, because 0 times anything is just 0. All right, and then we have another one with a complex conjugate. So here I'm going to multiply. What am I going to multiply by? 2 minus I. Good. So in the top and the bottom, 2 minus I. So we just changed the term in the middle. So I'm going to go 1 times 2 is 2. 1 times negative I is a negative 1i. I'm going to put the 1 there. 5 times 2 is going to be a 10, positive 10i there. And then 5i times negative I will be a negative 5i squared. Then we'll take the I squared. We'll make that a negative 1. So that's negative 5 times negative 1 right here. So that'll give us a positive 5. And then let's see, 2, negative 1i plus 10i will give us a positive 9i. 2 plus 5 is going to give us 7, 7 plus 9i. Okay, that's my numerator. Now my denominator, 2 plus I times 2 minus I. So change the color so we know they're different. Absolutely. Okay, so we'll just do first and last here. So the O and I are going to cancel out. 2 times 2, we get 4. I times negative I squared. And then that's 4 minus negative 1. So 4 plus 1 gives us a 5, and that's our denominator. So if I take this and put it underneath my 7 plus 9i, is that fully simplified? You can simplify that? They're all prime. Well, not all of them, but yeah, that's it. That's done. Because 5 does not go into 7 or 9. So we would be done there. And another way you might see this also is like this. 7 over 5 plus 9 over 5 with the I in the middle. So that would be fine as well. And you could put either one of these in, short answer. And then multiple choice, I think it's like the second way. So. All right, let's see what we got here. Okay, I think 1.5 is simplifying radicals. Oh no, this is still 1.4. This is 1.4b. 1.5 is quadratics. All right, so simplifying radicals. You have probably been taught, everybody's probably been taught different ways for simplifying radicals. So you could do a factor tree and find doubles. That's one way. That's not typically how I do it. Oh, we're frozen. I'm not moving anywhere. Hold on. It could be because my paper was on the mouse. Nope. Okay, now we're moving. Okay, sorry about that. All right, so now what we're going to do is we are going to, I'm going to show you guys my method for this. So we're going to write down all of our perfect squares. So we've got 1, which in this case, we don't really need to use 1 because it goes into everything, but we'll start there. Then we have 2 squared is 4. 3 squared is 9. 4 squared is 16. What's 5 squared? And 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. 12 squared. 144. Then you got to do 13, 14, and 15 too. So 13 is 169. 14, 196. 15, 225. All right, and then perfect cubes. You've got 1 cubed is 1. 3 cubed, 27. 4 cubed, 4 times 4 times 4, 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is, I think it's 343. Doesn't want to, there it is. I think I have to change the level of sensitivity on here. 7. It's not working. All right, we'll get that fixed eventually. 343. Okay, so the reason why we write this down is because we want to recognize these numbers. So what we want to do when we have a number to simplify is we're going to try and find the largest, either perfect square or cube, depending on what's going on, that can go into that number. Then we're going to split it into those factors and then simplify. Oh, 8. You're right. Thank you. 2 cubed is 8. I went straight from 1 to 3. Thank you. Okay, so let's take a look here. Oh, these are perfect anyway. But the question here is, I've got the negative under the radical. So am I going to, well, actually, it's not a multiplication problem, so never mind. So let's go ahead and simplify the negative under the radical. So that is where the I is coming from. So what we're going to do here is I'm going to take this minus sign, I'm going to change it to a plus, and I'm just going to put an I right in front of it. So now I have I radical 64 minus I radical 25. Now these are perfect squares, so I can just now take the square root. So that's going to be I times 8, so I make that 8I. And that's going to be I times square root of 25, 5. That's going to be 5I. We want to put the number first. And then 8I minus 5I gives us 3I. And we are simplified. Okay, then number 2, we're going to do the I first. So I'm going to take the negative here, make it an I. Then I'm going to multiply. So I'm going to go I radical 8 times radical 3. So multiply under the radical. 8 times 3 is going to give us a 24. I'm going to keep the I that is in front. And then here I've got 6 times I, so that's going to give me a 6I. And then I have 8 times 12. That's going to give me 96. Okay, then we want to simplify these radicals. So I'm going to first start with the number 24, and I'm going to think back to that list. These are squared, and anything on that list that goes into 24. So I go down the list and I say, okay, well, 4 goes into 24, and that's on the list. So 4 times 6 is 24. So what I do is I split this, but when I split it, they're still under the radical. Okay, because radical 4 times radical 6 gives us 24. Then take the square root of the perfect square. Okay, so the square root of 4 is 2. If there's anything in front of the radical, bring that down. So this I is going to come down as 2I radical 6. Okay, now the first term is simplified. So then 96. So I think about that list of perfect squares and I say, what goes into 96? And did anybody find anything yet? 16. So you want to do the largest one. So 4 goes into 96, right? But it's not the largest perfect square. So if you take the 4 out, you're going to get 4 and 24, which then 24 can be simplified as well. So you always want to find the largest one that can go in. So a tip would be to start with numbers lower than 96 that are on that list. So 96 divided by 49. Okay, that doesn't work. 96 divided by 36. That doesn't work. 96 divided by 25 doesn't work. And go in descending order on that list until you find one that works. Okay, so you get 16 and 6. They stay in the radical. Then take the square root of the perfect square. So the square root of 16 is 4. And then bring down anything in front. So that's 6I times 4 in front here. So that 6I times 4 would give us a 24I radical 6. And there's a plus sign in between. And then the like terms, you've got 2I radical 6 plus 24I radical 6. The endings are exactly the same. The I radical 6, so you can add the 2 and the 24. So that would give you a 26I radical 6. Correct. So you can multiply anything under the radical, but adding and subtracting, the numbers have to be the same. All right, let's look at number 3. We have 5 radical 90 plus 6 radical 40. All right, so perfect square that goes into 90 I can start with 64 and go down, 9. Yeah. And another way to think about that is, okay, look at the other number, 10. Does a perfect square go into that? No. So that works. So 9 times 10 gives us 90. Take the square root of 9, which is 3. And then this 5 that was in front of it will come down as multiplication. So 5 times 3 will give us a 15 radical 10. And then 6 radical 40. I'm just going to move this over here so it's easier to see. I think that should be just 4 and 10 again. So 10 again, yep. 4 times 10. And then the square root of 4 is going to be 2. Bring the 6 down. 6 times 2 will give us a 12 radical 10. Okay, then I'm going to add these together. So 15 plus 12 is going to give me a 27 radical 10. All right, number 4, we're multiplying. So it is being squared. We want to make 2 copies of it. So I'm just going to cross out the squared and I'm going to write another copy. And then I am going to FOIL. So they're the same. So now you have to do all of the foiling. Okay. Only when the signs are opposite is when you would not. So here I'm going to go square root of 2 times square root of 2. That's going to give me square root of 4. Okay, root 2 times negative 4 root 3. So multiply the numbers under the radical. That's going to give you a negative 4 root 6. Okay, then in the middle, same thing. So negative 4, 2 times 3, 6. And then negative 4 times negative 4, the outside numbers, gives you positive 16. And then root 3 times root 3 gives you root 9. So there's definitely some things we can simplify here. We have square root of 4 is 2. So that'll just become a 2. Square root of 9 is 3. So that becomes a 3. And so let's see. Let's make this look nice. So 2 minus 4 radical 6 minus 4 radical 6 plus 16 times 3, which is 48. And then combine like terms. That's going to give you a negative 8 radical 6. And 16 times 3. Oh, okay. Yeah, that's okay. And then 2 plus 48 will give us 50. And we cannot simplify that root 6. So that's our answer. We want to put the 50 in front. So 50 minus 8 radical 6. All right, and then we have the same rules in number 5 that we did for the i's. So when I'm dividing, I'm going to multiply again by the complex conjugate here. So that complex conjugate would be what? Good, yes, 1 plus radical 3. So we're just changing the sign in the middle. So then we're going to FOIL on the top and the bottom. All right, so we got 2 times 1 gives us 2. 2 times radical 3 will give us a 2 radical 3. 6 times radical 1 will give us a 1 radical 6. And last term, you get root 18. So let's go ahead and simplify this. So nothing there, Nothing with the 6. What about 18? 9 and 2. Yeah, 9 times 2. And 9 is a perfect square. That becomes a 3, radical 2. So I'm going to get 2 plus 2 radical 3 plus 1 radical 6, which is radical 6, plus 3 radical 2. That's my numerator. Sometimes it doesn't combine precisely, and most of the time that's because I made up the problem and didn't go through all the processes to make sure it was a nice, concise answer. It's not always going to be a nice, concise answer. So sometimes it's long like that, and that's okay. All right, then the denominator, we're going to go first and last. So 1 times 1. And then you got negative radical 3 times positive radical 3 will give you a negative radical 9. Or you could just take the radical off, since you know that that's what's going to happen, because the square root of 9 is 3. So this just becomes 1 minus 3, so negative 2. So you're going to put the whole thing over a negative 2. Now, because this doesn't have a 2 in front of it, and this has a 3 in front of it, which doesn't go into 2, you're not going to simplify. Unless you broke it into individual fractions, which actually in this case you do not need to. So you can leave it like that. All right. Now we have one with cube roots. So we want to go to that second list. So second list is shorter. We only went up to 7 because we're not really dealing with really large numbers here. So on that second list, 81, what's going to go in there? 27, yeah. 27 times 3 gives us 81. So when I break this out, it's just cube root instead of square root. So cube root of 27 times cube root of 3. Then take the cube root of 27, which is 3. And then you have 3, and then cube root of 3. A lot of 3's here. I'm going to put a multiplication symbol in between just so it doesn't look like 33. All right, and then 24 on that list, what goes into 24? 8, the one that I forgot, right? So I'm going to break it out over here so we've got room. So we've got cube root of 8, cube root of 3. 8 times 3 is 24. Then take the cube root of 8, which is 2. 2 times cube root of 3, and then it's a minus. So the endings are exactly the same, cube root of 3. So you can just do 3 minus 2, which is 1. Do we need that 1? No. We do not. So that's it. All right, I'm going to skip the practice problems for now. I'll make a YouTube for them later. I just want to make sure we actually get through everything today. Yeah, I'll do them, and I'll post them for you guys tomorrow. All right, quadratics. So you've got a couple different ways that you can solve with quadratics. You can solve by factoring. So if you can factor, always factor because it's the easiest, fastest method to solving. You can solve using the square root property. Completing the square, which that's new. And then quadratic formula, which is somewhere on here. Okay, so those are your 4 ways that we're going to solve. You do not, if it tells you on your homework to solve it a certain way, that's because that's the best way to solve it. So you want to do that. You can always use the quadratic formula for any of these. Okay, on the test, if it is a short answer problem and I ask you to solve it a specific way, you have to solve it that way and show your work. All right, so let's solve by factoring here. We can factor this. So we want to say, all right, it's a monic trinomial. We want to put our x's here. And we say, okay, what multiplies a 3 and adds a 4? 3 times 1, right? 3 times 1 is 3. 3 plus 1 is 4. We just have that extra step after factoring where we set it equal to 0. So we're going to take the x plus 3 and set it equal to 0, and the x plus 1, and then we're going to solve each one individually. So here I would subtract 3, and I would say, okay, these cancel. 0 minus 3 gives us negative 3. And then here I'm going to subtract a 1, and 0 minus 1 gives me a negative 1. So my answers are negative 3, negative 1. Notice this, okay? The x is squared. That exponent, that's going to tell you how many solutions you have. Okay, and we're going to go more into that a lot more in depth in chapter 3. Okay, so if it's squared, you're going to have 2 solutions. Sometimes it can be the same number twice, but it's still 2 solutions. So the second one, a lot of people will want to multiply all of that out and then use a quadratic formula or factor, but that would just take, you could do that, it just takes longer. So the square root property, when it's in this form, is going to be your easiest thing. So that's going opposite operations. So square root property, if you don't recall from intermediate algebra, you're going to go like this. Your first step is going to be to isolate the square term. So that's 4 times x plus 2 squared. So I'm going to do the opposite of times here, and I'm going to divide both sides by 4. These 4's are going to cancel, and I'm going to get x plus 2 squared equals 48 divided by 4, 12. Once the square term is isolated, then you're going to take plus or minus the square root on both sides. Okay, so what that ends up doing on the left is it cancels out. Square and square root are opposite operations. So those cancel each other out. The plus or minus goes away when that happens. And this is x plus 2. So it's basically, it's freed from the parentheses. And that equals plus or minus the square root of 12. And I'm going to leave a little bit of space here in the front, because then what I'm going to do is I'm going to isolate x, or solve for x. So I'm going to subtract a 2. So I'm just going to put that right here, because you don't want to put it after the radical. You want to put it before the radical, because the radical will come last when I'm solving. And then you're going to simplify the radical if you can. Okay, so let's see. We've got x equals, can I simplify 12? Square root of 12? Yeah, 4 goes into 12. 4 is a perfect square. Square root of 4 is 2. So this becomes negative 2 plus or minus 2 radical 3. All right, completing the square, this is new. So I've got the steps on here for you. I'll give you a second to finish this one, and then we'll go on to, we'll do bright pink. All right, so completing the square, you will be told to complete the square if that's the best method, but typically it's going to be some sort of quadratic that you cannot factor. Okay, if I move the 5 over, I'm not going to be able to factor that because there's nothing that multiplies to 5 and adds to 2. Okay, so my next best thing here is to complete the square because my middle term is even. Okay, and that helps me. You are going to have to keep completing the square as you go through this class and into pre-calc because that's how you're going to solve conics. So pre-calc and trig. So you will continue this. All right, so we've got x squared plus 2x equals 5. First thing is to isolate the constant, which is that number 5. It's already isolated. So let's say it were not. Let's say it were like x squared plus 2x minus 5 equals 0. In that case, then you would just add the 5 to both sides. And then you would get x squared plus 2x equals 5. Okay, so it's already in that form. I'm just telling you if it's not. The constant's a number that's by itself. The next thing, this is the complete the square step. So you're going to do b over 2 squared. So remember, in a quadratic, quadratics are in the form, we'll write it over here, ax squared plus bx plus c. So the b is the term with the x. So it's this number right here, 2, positive 2. So b over 2 squared is going to be 2 over 2 squared. So 2 over 2 is 1. 1 squared is 1. So we do b over 2 squared. And then we're going to add it to both sides. So I'm going to change the color. So for effect, I'm going to add a 1 to both sides. So I'm going to sneak it in right here and right here. Okay, so now what I have on the left side is x squared plus 2x plus 1. So what I'm going to do is I'm going to factor, and that should be a special factor where it's a perfect square trinomial, meaning it's the same thing twice. Okay, what multiplies to 1 and adds to 2 is 1 and 1. Okay, 1 times 1 is 1, 1 plus 1, 2. So I factor that, but when I factor it, I'm going to write it like this. X plus 1 squared, because it's the same thing twice. On the right, I'm going to add. 5 plus 1 is 6. And then what we just did in the previous problem, the square root property. I'm going to take the square root of both sides. Square root and square will cancel each other out, so this will become x plus 1 equals plus or minus radical 6. Then I'm going to solve for x. So I'm going to subtract this 1, put it in front of the radical. And then simplify, if I can. Can I simplify root 6? No. It's got to be one of the numbers that's a perfect square. So 4 would be the only one, and that doesn't go into 6. So that's it. So it takes practice. Anytime we do something new, we want to practice it. So we have another one underneath. All right. Let's go through that one. So step 1, isolate the constant. So we're going to take the minus 35. We're going to move it to the right. So we're going to add it to both sides. So that's going to give me x squared plus 6x. I'm going to leave some space because remember, you're going to end up adding something over here. So leave some space for yourself. Equals 35. Okay, next step. Let's identify b. What's b going to be here? 6. So b over 2 squared. So 6 over 2 and then we're going to square it. Okay, so that's going to be 6 over 2 is 3. 3 squared, 9. We're going to take that 9, we're going to add it to both sides. Sorry. Okay, and then the next thing we're going to do is we're going to factor on left. X squared plus 6x plus 9. What multiplies the 3 and adds, or I just gave you the answer. What multiplies the 9 and adds the 6? 3 and 3. So this is going to become x plus 3 squared. And then 35 plus 9 is 44. Okay, then we do the square root property. That's the last step. Kind of. Square root both sides. Square root and square cancel each other out. This becomes x plus 3 equals, leave some space, plus or minus square root of 44. And then solve for x. Take that plus 3, subtract it. All right, x is isolated. Can I simplify the radical? Yes. Perfect square that goes into 44. 4 times 11. Yes. And then that 4, we'll take the square root to radical 11. So negative 3 plus or minus 2 radical 11. Okay, you might also see an answer. I don't think typically it does, but if you split it into 2, right, it would be negative 3 plus 2 radical 11, comma, negative 3 minus 2 radical 11. I don't think you have to do that. There is a plus or minus button on that toolbar on my math lab that you can use. All right, so that's completing the square. We'll do another practice problem in the practice. Now we've got the quadratic formula. You guys remember that one? All right, so quadratic formula, you want to be in the form ax squared plus bx plus c equals 0. That's a quadratic. That's standard form of a quadratic. The formula itself is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So solve using the quadratic formula means that's the best way to solve this problem. Actually, I think this one you could factor, but we'll do the quadratic formula. So we're going to identify a, b, and c. So a is going to be the number with x squared. That's going to be 2. B, the number with x, negative 1. Okay, if it's by itself, it's just a 1. And we don't carry the x's into it. It's just the numbers that are in front. Okay, and then c is also negative 1. So we're just going to pop those in for the letters and then simplify. We've got negative b, so that's going to be negative 1 plus or minus square root, let's see, b squared. So negative 1 squared minus 4, a is going to be 2, c negative 1, all over 2a, so 2 times 2. Okay, so then what I like to do here is, well, first of all, this negative, negative, let's make that positive. Positive one. I'm just going to work underneath the radical. So order of operations, do the exponent first. Negative 1 squared is going to be positive 1. And then this is going to be, you can do this two ways. Okay, people always ask this, is it a negative 4 or is it minus 4? It's both. Okay, you could do negative 4 times 2 times negative 1. That's fine. Or you could do minus, which is what I like to do, 4 times 2 times negative 1. Okay, so 4 times 2 is 8, times negative 1 is negative 8. So now I look like that, 1 minus negative 8, which then turns into 1 plus negative 8, plus 8, positive 8, sorry. Double negative turns into a plus, 1 plus 8, and that'll give me 9. That's still under the radical, I'm just trying to work that out. So we're looking like this, 1 plus or minus radical 9, and then 2 times 2 is 4. Okay, then once we get there, we simplify as much as we can. So we can actually take the square root of 9. So if you can actually take the square root of 9, you're going to break this out all the way until you get two numerical answers. So square root of 9 is 3. So this is 1 plus or minus 3 over 4, which means you're going to do this. 1 plus 3 over 4, 1 minus 3 over 4. You're going to break it out into the plus or minus. So 1 plus 3 is 4 over 4. That'll give you a positive 1. 1 minus 3 is negative 2 over 4. That'll give you a negative 1/2. And those are your two solutions. Remember, we start with squared, two solutions. All right, let's do the quadratic formula again. Okay, so then this one here, let's see. We have A, 3. B is the number with x, so you've got a positive 7. C is going to be a negative 1. So we've got negative B, so negative 7, plus or minus the square root of B squared, so 7 squared minus 4. Then A is 3, C negative 1, over 2 times A. All right, let's see. Negative 7 stays negative. 7 squared, 49, minus 4 times 3 times negative 1. So 12, negative 12. So 49 minus negative 12 turns into 49 plus 12, which gives us 61. So I have negative 7 plus or minus radical 61. 2 times 3 is 6. So let's look at that 61. I'm not sure you can simplify that. So I'm going to start with 49. No. 36 does not work. 25 we know does not. 16, no. Yeah, I think it's prime. So that's it. So nothing goes in there, which means then you're done. Okay, if you can't simplify it, circle it, you're done. All right. The next problem, we have fractions. And we've got variables in the denominator. The first thing we want to do is find the least common denominator. when we are dealing with variables, basically what you're going to do is you're going to write down all of the denominators, just one of everything. If it appears twice, if you already have it written, then you're good to go. Okay, so first thing I'm going to do here, actually, I'm going to rewrite this so I've got room. All right, and then we're going to find the LCD. So I need one of everything. So I need an x. I need an x plus 2. The x plus 2 is its own term. So I'm going to go like this. And I need a 7. So my LCD is actually 7x, x plus 2. So I want to clear the denominators, okay, because I don't want to deal with fractions anymore before I start solving this. So I'm going to multiply each term by this entire LCD, okay? So everything is going to get a 7x, x plus 2, just next to the top term. Okay, then let's cancel out what we can so we can clear the denominator. So these x's cancel. In the second term, the x plus 2's are going to cancel. And on the right, the 7's are going to cancel. All right, so here I have 7 and then x plus 2. And then a 1, you don't need the 1, times 1. Plus 1 times 7x, which is just going to be 7x, equals 1 times x, x plus 2. Okay, so I've got some things to multiply out, but I do not have any more fractions. They're gone. All right, so let's go ahead and distribute. So 7 times x is going to give me a 7x. 7 times 2 will give me a positive 14. Bring over the 7x here. Distribute this x times x squared, x times 2, 2x. Okay, on the left, I've got 7x plus 7x. I'm going to go ahead and combine that to make 14x. All right, so I have an x squared in here, which means it's a quadratic, which means I need to move everything to one side. I need to set it equal to 0. That's the first thing you do when you're solving a quadratic. Okay, so set this equal to 0. Because this x squared is positive on this side, I'm going to move everything to the side where the x squared already is. So I'm going to take the 14x and I'm going to subtract it from both sides. And then I'm going to take the positive 14 and I'm going to also subtract that. So that on this side, everything cancels and I've got a 0. It doesn't matter which side the 0 is on. Okay? And then here I've got, let's see, x squared. 2x minus 14x is going to give me a negative 12x minus 14. So now I have a quadratic, so I want to work on solving this. So let's see. Can I factor that? What's it going to factor to? I don't think I can factor that. 1 and 14 or 2 and 7. That's not going to work. Okay, that's fine. We can complete the square or we can do quadratic formula. Complete the square. I think we got another complete the square one after this though. Let's do the quadratic formula. But if you want to do complete the square, that's fine. All right, so you've got a is 1 in front of the x squared, b negative 12, c negative 14. So let's see here. You've got negative b, so negative negative 12. That'll make a positive 12. Plus or minus negative 12 squared minus 4 times 1 times negative 14 over 2 times 1. All right, so negative 12 squared is going to be a positive 144 minus 4 times 1 times negative 14, negative 56. So that double negative there will turn to positive. So 144 plus 56, I believe, is 200. Yeah. Well, that's nice. So I'm going to get this. 12 plus or minus the square root of 200 over 2. Can I simplify that? Yeah, what goes into 200? Perfect square. 100, right? 100 times 2. Square root of 100 is 10. So we've got 12 plus or minus 10 root 2 over 2. Am I done? Nope. 12 and 10 are both divisible by 2. What about the 2 in the radical? No. Not going to touch a 2 in the radical because the 2 underneath is not in the radical. Okay? So that's like an x. So that's untouchable once that's simplified. So it's just 12 divided by 2, which is 6, plus 10 divided by 2, which is 5. And then you're going to keep that radical 2. That's just like it were an x. We don't touch it. All right. Give just a sec here. We got a couple more. What do we got? Practices. Okay, so I'll go through these practices with you. Perfect. Well, I want to get to the, no, there's, oh, I'm looking at the wrong page. Yeah, there's 4 more. I want to get to the one with the negative exponents for sure. We got 20 minutes. We're good. Let me, actually, I'm going to stop.